Today's lesson is lesson 5.5, proportional and non-proportional relationships. Believe it or not, proportions are the basis of all math that you do. And so this is an important lesson to go through today to kind of give you an idea of what proportion is. You did it last year, so it shouldn't be new. And you've probably done it the last few years. So let's get started. So a few vocabulary words I have for you, what proportion is. And to be in proportion means you have a constant rate or ratio. So something that's consistent. I'm going to use the word consistent a lot because it's something that's consistent the whole time. The constant of proportionality is what that thing is that's being consistent. Is it being multiplied by 2 each time? Is it being multiplied by 5 each time? Well, that would be the consistent ratio or the constant. Non-proportional means when two quantities do not have the same ratio. In other words, it means they're not consistent and they're not in proportion. A long time ago, we talked about 3 different ways to tell if something is in proportion. So let's just write that down. 3 ways to tell if in proportion. Okay. So the first way, and I'm going to extend that again, is you can look at it and you can use reducing. And I'll show you how to use this a little bit more coming up. The second one you can tell if something is in proportion is by using division. Okay? And whatever happens here, it has to be the same. If they're the same, if you reduce things and they're the same, they're in proportion. If you divide things and they're the same answer, they're in proportion. And the third thing is you can use the butterfly method to tell if something's in proportion. This is how you would use it. Let's say you're gonna compare these two things to see if they're in proportion. Well, you would take 7 times 3, that gives you 21. And you take 1 times 12, and that gives you 12. These things are not in proportion. So you can use the butterfly method to determine if things are in proportion or not. Okay, so how to tell, looking at a table, you can actually create a equation from something that's in proportion, okay? And this is the equation. So a lot of times when we look at things, it's going to be in a table or it's going to be in a graph. Today, everything's going to be in a table, I believe. Well, I think so anyway. And we are going to give it an equation. So this is the equation we're going to use. It's actually known as a direct variation. Direct variation would be like the rule, and it's y equals kx. K is the constant, something we have to know. X is the number that can change, but you're going to be putting things in for that. And y is going to be the answer. And I'm going to show you how we're going to come up with some equations from tables and proportional relationships in a second. So just know that y equals kx. It's the equation known as the direct variation. And x is what you're going to change. K is going to be the constant, what's consistently there all the time. And y is the answer. Okay, so we talked about this already. How can you tell if something is in proportion? I talked about the butterfly method. You can use division and you can use reducing. And let me show you how to use some of this. Okay, so here's an example. Here's a table and they want to know if this is in proportion or not. There's a lot of things you can do to figure this out, but what they want you to do is basically look from, if you have a table, usually this is your x and this is your y column, okay? So usually the first is the x, the second's the y. So you're going to look between here and here, and here and here, and here and here, and here and here, and figure out what's being consistent. What is consistently happening over and over and over again? How are you going from 1 to 3? How are you going from 2 to 6? How are you going from 3 to 9? How are you going from 5 to 15? Okay, so is it in proportion? Now there's a lot of ways we could do this. Now let's talk about some of our ways. We could do our butterfly method. Okay, so 1 times 6 is 6, 2 times 3 is 6. Okay, so far it's in proportion. Okay, what if we do this? Well, 5 times 9 is 45, 3 times 15 is 45. Okay, I use the butterfly method to figure out, well, this is in proportion. Another thing I could do is I could say, okay, 1 and 3. Say 1, 3, 2, 6, 3, 9. I'm just going to write them in a horizontal way. 15. And then I'm going to reduce them. Well, guess what? They're all going to reduce to 1/3. So I know that's another way that's in proportion. So I showed you the butterfly method now, and I showed you reducing. You could also divide, you guys. You could take 1 divided by 3, 2 divided by 6, 3 divided by 9, 5 divided by 15, and guess what? You're going to get 0.3 repeating for every single one. Also in proportion. Okay, so 3 ways right there. So yes, this is in proportion. The constant, what's consistently happening? How are you getting from 1 to 3? How are you getting from 2 to 6? How are you getting from 3 to 9? Well, you can tell that you're multiplying by 3 each time. 1 times 3 is 3. I'm sorry, 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 5 times 3 is 15. So my constant would be 3. Now, how could you write the equation? Well, if we wanted to write the equation for it, it would be y equals kx. And since that 3 is the constant, it would look like this. Okay, so then what does that mean? That means that if I wanted to, let's say I put another number in my x column, let's put 10 in there. How could I use this equation to figure out what the y is going to be, or what's on the other side? Well, I would take your 3 times your 10, and that's going to give me what my y is. So this equation can be used to help you figure out what else is going to be in this table over and over and over again. If I would put 20 in here, I'd say, okay, well, what's 20? What would the other side be? Well, then I put 20 in here, and it would be 60. So you can use this equation to figure out anything else. But the thing is, it has to be in proportion to be able to write an equation. All right, so let's look at this one. Is the distance in proportion to the time? If so, find the constant. Well, what I'm going to do right away is I'm going to use one of my methods to determine if it's in proportion or not. Okay, so I'm going to figure out one of my methods. Well, I personally like the butterfly method because I think it's easy. So if I go 1 times 70, that's 70. Oh, 50 times 2 is 100. Well, I know that those two aren't equal. I know it's not in proportion. So no, not in proportion. And since it's not in proportion, there's not a constant. Okay, not in proportion, not a constant. All right, so let's do our own. So it's going to ask us to make our own chart. It says, David mowed 5 lawns. He made $50 altogether. Find the constant. Use the equation to determine how much he would make if he mowed 13 lawns. Okay, so he mowed 5 lawns. Altogether, he made $50. Well, first of all, I need to know how much he made per lawn. Remember when we talked about unit rate? Well, we need to know what he's consistently making for every single lawn. What is he making for every single lawn? Well, if I do 50 divided by 5, $50 divided by 5, this gives me $10. That means he's consistently making $10 per lawn. Okay. Okay, so let's use our equation. Now this is number 2, y equals kx. Where's that 10 going to go in there? If he's consistently making $10 for every lawn, that's going to go in for k. Okay, there's our equation. Now, it says how much would he make if he mowed 13 lawns? Well, where am I going to put 13 into that equation? I'm going to drop 13 right in here. So now this is what it looks like. 10 times 13, it would be he would make $130 if he mowed 13 lawns. Okay. All right, so Sherry bakes 6 cakes. She charges $24 per cake. I need to know what she's per cake. I think this should say she makes $24. So I think let's change that. She makes a total of $24. There we go. That makes more sense. So she bakes 6 cakes. She makes a total of $24. Okay, so what is the constant? I need to know what she's consistently making for every single cake. Well, I'm going to take 24. I'm going to divide by 6. That gives me $4 per cake. Okay. Now let's write our equation. Y equals kx. It's going to go in k. K is going to be the constant, so this is what it's going to look like. Okay, that's my equation. Now, how would I know if she made 20 cakes, how much she's going to make? Well, I'm going to take my 20, and I'm going to multiply by 4, because she makes $4 for every cake, so this is what it looked like. I think that's cheap. $4 for cake, that's a really cheap cake. She's going to make $80 if she makes 20 cakes. So finding the thing that's consistent is so important. That's also called, the thing that's consistent is, remember, is also called the constant of proportionality. Okay, so next thing we're going to do is we're going to complete the table. This is part of your homework today. This is what you'll have to do in your homework. So complete the table. For one ride, it costs $3. If one ride costs $3, it's pretty easy to figure out what 2, 3, and 4 rides cost 2 would cost $6, 3 would cost $9, 4 would cost $12. And I know that from looking at my unit rate that remember we talked about unit rates a few days ago. Okay, so my next question, oops, shoot. I was just going to move this up a little bit so you guys could see it a little better. So what's the constant? What's consistently happening? Well, it's always going up by $3 per ride. That's my consistent thing. It's consistently going up $3. Why is it always changing? Well, it's always changing because my rides are changing too. So if my rides are going to go up, so is my cost. That's pretty simple. Now let's say if they ask you to write an equation. What would the equation be? Equation would be y equals kx. Where's that 3 going to go? 3 is going to go in my constant. Now let's say we added this. How can I find out what this is? Well, I could take my 10 and I would put in from x, because when I have a table like this is usually my x and this is usually my y. So it'd be 3 times 10, and I know 30 would go down here. So we can use that equation, like I said, to keep finding things out that could potentially be in our tables. Other than that, I really don't have anything else for you. Just make sure you're being consistent on some things. And if you're not consistent, there's no constant. A lot of times, instead of asking you to write the equation, it's going to ask you to write what the constant is. And that's what they mean by the constant of proportionality. So that means the consistent thing is what's consistently changing. So if you have any questions, let me know, and I'll talk to you tomorrow.